I take immense pleasure in introducing to you all uh, the well-known expert, Professor Saifur Rahman, for today's webinar. And Professor Saifur Rahman is the founding director of Advanced Research Institute at Virginia Tech, USA, where he is the Joseph Loring Professor of Electrical and Computer Engineering. He also directs the Center for Energy and Global Environment. He is a Life Fellow of IEEE and an IEEE Millennium Medal winner. He was the president of the IEEE Power and Energy Society for the year 2018 and 2019. He was the founding editor-in-chief of the IEEE Electrification Magazine and IEEE Transactions on Sustainable Energy. He has published over 140 journal papers and he has made over 400 conference and invited presentations. I'm sure many of you would have seen him in keynote speeches at Singapore and many other countries and opening ceremony of various conferences organized by IEEE and IEEE Power and Energy Society. So in 2006, he served on the IEEE Board of Directors as a Vice President for Publications. He is a distinguished lecturer for the IEEE Power and Energy Society and has lectured on renewable energy, energy efficiency, smart grid, energy internet, blockchain, IoT sensor integration, and many other topics in over 30 countries. He is the founder of BEM Controls LLC, a Virginia, USA-based software company providing building energy management solutions. Even in Singapore, we are following some of his ideas which he has presented in 2018 during the ISGT Asia, where he has given us many inputs on energy management solutions. Thank you, Professor, for your inputs. He has served as a chair of the US National Science Foundation Advisory Committee for International Science and Engineering from 2010 to 2013. He has conducted several energy efficiency, blockchain, and sensor integration projects for Duke Energy, Tokyo Electric Power Company, the US National Science Foundation, the US Department of Defense, the US Department of Energy, and the state of Virginia. On behalf of our chapter and the IEEE Singapore section, I welcome you, Prof Saifur Rahman. Over to you, and I will share this screen and you can start your presentation. Thank you once again for accepting our invitation. We are really honored to have you here.
Thank you, Nayagi. Thank you very much. Okay, very good. I can see the full screen. So thank you everybody for coming to this session today from many countries in Southeast and South Asia. I am honored to be in front of you, even not face-to-face, this is fine. So this is the title, an energy internet platform for sensor-driven transactive energy applications. The three key items here, energy internet, sensor-driven, and transactive energy. And I'll explain those one at a time. So if we can go to the next slide, Nayagi. On the next slide, number 2, you will see this question, what is the internet? That's a question people ask me, or what is energy internet? We know what is internet. Like we know, for internet, it allows information to flow to anywhere, anyone, from anywhere, anytime. That's internet. Energy internet, this is in the planning stages now. We have not built it yet, but we have pieces, we have parts of it in different parts of the world. It's a vast network that will allow efficient distribution of electricity to anyone from anywhere. Like I can buy something like right now, face mask on Amazon, and they come from China. That's an example of anyone from anywhere. Similarly, because of time zone difference, when it is evening in Singapore, your peak load is growing because of air conditioning. It's morning in the US, where I am, is nice and cool, not as much AC demand right now. So if there was energy internet, you could buy literally power from Virginia to Singapore to meet your peak load and don't have to turn on high capacity generation. That's what I mean by efficient distribution of electricity to anyone from anywhere. That's the concept. How would that happen? It has to allow smart sensors, IC technologies, and algorithm, explain in a minute, to facilitate power supply in real time, enhance storage applications, and integrate renewable energy into the grid. Take one at a time. Smart sensors. You have to know, and I'll talk about that more later on in a few slides, what is the current status of your demand? What AC is running, what lights are on, what plug loads are functioning like refrigerator, that's sensors. ICT will allow you to communicate between these devices to collect information. And power supply has to be done real time by definition. What do I mean by enhanced storage applications? For example, if I knew last night that Singapore will buy power from me, from my building, let's say, at 8 in the morning, my time, 8 in the evening, your time, I would recharge my batteries overnight to make sure I have enough capacity to supply what I am asked to do. Similarly, last item, integrate renewable energy into the grid. Same thing. Maybe you depend on solar, maybe still sunshine there, but for some reason become cloudy. So what do you do in that case? You look at storage, buy power from somebody else. All that mix has to be functioning for the energy internet to function efficiently. Next slide, please. Okay, this is my favorite slide. We know Amazon, we know Alibaba. So there are three ways we do transactions. One is one-to-one, that is between individual users for bilateral transactions. As you know, on Amazon and also Alibaba, I can buy face masks, I've done that, from a particular vendor, one person, one company, I deal with them. So that's one example of one-to-one. One-to-many, that one electric utility, like Singapore Power, selling to many customers. That's one-to-many. Then many-to-one. Many customers sell to one electric utility. For example, in the US now, many rooftops have solar. So these solar rooftop owners, when the demand is less than what they're producing, it happens in Washington, DC right now, they can sell to the local power company. So these are the models we will use for energy internet transactions. Next one, please. So here you go. So all transactions must be done in real time, which is needed. Other thing is all network constraints must be met. Let's think about this. When I buy something from Singapore or China or Indonesia or Thailand, whatever the case may be, they will get my order and they'll put that on a freight service, let's say DHL or whatever, or FedEx or UPS, and it'll come. If the plane is full, you'll wait till the next plane, maybe next day, and they'll come to me one day late. That's what it is now. If I want to buy power, or you want to buy power from Virginia now in Singapore, I cannot tell you, my line is busy, network is congested, we'll give you power tomorrow. It doesn't work. That's the difference between goods and electricity. That means there must be enough available transmission capacity so that when you press the switch to buy power from US, power will be there momentarily. This is the difference between Alibaba, Amazon, and the energy internet. Next slide, please. Good. So this is the vision for the future grid. I got this slide and modified this from a presentation given in Thailand, in fact, last year, by the State Grid Company of China, SGCC. The three components, most of us know this already. On the lower left, we have electricity production and storage. Then you got transmission, obviously, and then you got consumption of electricity on the lower right. And in between, if you look at the bottom of the slide below the green oval, energy flow, data flow, business flow. If you are a power company person, like a transmission operator, like here, Dean is in the audience, they're looking at energy flow, meaning they have to make sure the demand of electricity is met instantaneously. That's energy flow. The new things are the two things here, data flow and then business flow. So what do I mean by data flow? That means in smart grid, in smart meter, you can keep track of in real time how much power a given consumer or building is using in real time. That's data flow. That power comes from the substation to your building, and data goes back from your building to the substation to tell them what's going on at every home, every business, every building. That's data flow. Add to that is business flow. If I, as a building owner, want to sell my solar, my battery storage capacity back to the distribution network, I have to have some incentive. So power company in real time can broadcast prices. If you sell power at 7:25 p.m. Singapore time, you'll get so much per kilowatt hour. Those are two new things. Energy flow is going on for 100 or more years. Data flow is happening because of smart grid, and now energy internet will make the business flow possible. That's the structure within which we are building energy internet. That's the idea. So next slide, please. Okay, good. Now is the challenge. How do I map energy internet into the future grid? The grid exists, but grid can do with smart grid applications, data flow, but it cannot do business flow at this time. And I'll give an example later on my presentation here, how we presenting this idea. So a simple thing you got, something very important here. You see on the upper left-hand side, we call it internet. This is new. Now, all the data about my offer to sell electricity to the power company is posted on the internet in some cloud somewhere. So power company can see that information from the cloud and know how much power is available to be supplied from the customers, how much they want to use, what battery storage is available, what solar capacity can be put on the grid. All that is in that database. And then you got many things. You got transmission line, we got network, we got charging station, electric vehicles, we got at the bottom rooftop solar, we got battery storage, we got wind, we got big facilities, we got storage of gas storage, we got battery storage, we got oil well where demand is fluctuating. All this stuff has to be brought under one umbrella. So I'll leave that up to your PhD students in Singapore to see how they can use some of these ideas to do interesting research work. Next slide, please. So this is the difference. Then those who can read Chinese will find this interesting. We have on the left half of the screen, future power system. And on the right half of the screen is future power system integrated with modern information technology. That means smart grid is smart because it has IT built in to transfer data back and forth between the customer and the utility. So you can, things inside are familiar to you. Got like on the right-hand side, we got rooftop solar, we got IT applications, we got buildings, we got transmission lines, nothing new here. So the future power system on the left-hand side will have, we would not get rid of our coal and gas turbines and nuclear plant and hydro plant anytime soon. They'll last another 30, 40 years or so. So that is there, but then we're adding solar, wind, storage, electric vehicles, all that makes it more interesting and more complex. So next slide. Okay, now here is the summary of what I have just said. Future power system, pathway to energy internet. So first of all, let's start on the lower left. It has to be flexible and resilient. Flexible meaning if for some reason solar is not available at 3 o'clock in the afternoon, it must be flexible, meaning there must be something else available to make up for that loss. Could be battery storage, could be demand response, could be other sources. That's the flexibility. Resilient means suppose the solar fails, battery storage fails, how does it recover from that state? So this is resiliency. Resiliency means recovery from failed state. Then on top of that, on the left-hand side, open and sharing. For any internet to work, like the online buying and selling, is open and sharing, right? Open means all the suppliers have given their price, quantity online. That's open for the buyer to look at. And that information is shared globally with anybody who is logging on to the Amazon account right now. It's open and sharing. Similarly, for power, the storage battery capacity, solar capacity, demand response opportunity has to be broadcast and made available. Then on top, extensive and interconnected. For this to be functioning, people from anywhere have to be able to see and buy and sell in real time. For that to happen, on the right-hand side, it has to be smart and interactive. Smart meaning respond quickly, and interactive meaning I can know the price and I can decide to buy. Now, I want to add one layer of functionality here. By interactive, I mean I can even start negotiating. That I am a seller. I put the price on the board that I'm selling 5 kilowatt hour for the next hour at 5 cents a kilowatt hour. And then somebody says, fine, but I need 8 kilowatt hour. Can you sell me 8, not 5? I pay you more money. It's interesting. So this is happening in other business. I can talk later on if you like. Then last one, secure and controllable. Meaning, secure meaning, if I put an offer for price and quantity, that has to be deliverable to the buyer. That's security. And to what I mean by controllable, I may have the option, if I want, to control raise the capacity or control other ways of controlling my building so I can meet the required supply that I promised. Those are the basic building blocks. Next slide, please. We'll see on the next slide, this is the functions of the energy internet. Again, the top part, we know. It is the grid business, we know very well. The bottom part is grid business plus other features. That includes energy service, which is demand response buying and selling, big data, PV in the cloud, meaning PV capacity that I have would be posted in the platform. It'll be electric vehicle, energy finance. We'll talk about how much you pay to buy or to sell, how much you earn by selling, and equipment meaning electric vehicle charging stations. So this is interesting. If you see the oval on the left-hand side, the lower oval, we have sensors, the network, platform, application. The summary is it must be energy Internet of Things, EIoT, ubiquitous, meaning it should be there all the time, always, without us knowing. It's like you breathe air. You don't have to think about what air I'm going to breathe. You just breathe and it's there. So ubiquitous means it would be so transparent, so widespread, it becomes part of our life. That's what has to happen. Again, so again, this is long-term. We can see how we build our understanding to reach that goal. Next slide, please. Okay, now this is the flow. Energy flow, information flow, business flow. You remember a few slides back, I talked about energy, data flow and business flow, same thing.